Hello students. So you all have studied two laws of motion given by Newton, Newton's first law and Newton's second law. Now today we will start with the third law, that is Newton's third law of motion. As I have told you, it is based on two forces, that is action and reaction forces. And what are these action and reaction forces? Let us suppose there are two bodies, okay? If first body applies some force on second body, let us suppose this is F21. Only first body will not apply force on second body. Rather, second body will also apply same force, same magnitude of force on first body but in opposite direction. If first body is applying force on this direction, then second body will apply same force on the opposite direction. So, statement of Newton's third law of motion is, for every action, there is an equal and opposite reaction. And how mathematically you can write? Mathematically you can write it as F12 is equal to minus F21. F12 and F21. The magnitude of both the forces will be equal. But what is this minus sign signifies? It signifies opposite direction. Okay, the values of both the forces will be equal, but one of the forces will be opposite to the other force. So we will put minus sign over here. So this is the mathematical form of Newton's third law of motion. F12 is equal to minus F21, or you can write F21 is equal to minus F12. Both are correct. Okay. Now moving on to the examples of Newton's third law. When we are talking about Newton's third law, there are many common examples you can observe daily. Like for example, when we walk. Okay. While walking, what you do? You push the ground in backward direction with one of your foot, and in turn what happens? You can move in forward direction. Now what is that thing that makes you move forward? It is that reaction force that ground puts in your foot or in your body. Okay, so the force that you are applying on the ground is action force, and the same force ground applies on you, that is the reaction force. And see, the direction of both the forces are opposite. You are pushing the ground in this direction and the ground is pushing you in forward direction. And more the force you will apply on the ground, the more reaction force the ground will apply on your body. You can observe where while running you apply more and more force in the ground, and the more faster you can run. And there is other common example like swimming. In swimming, what a swimmer does? He pushes the water in backward direction with his hands, and that is the action force. And as a reaction, what water does? Water pushes him in forward direction. So the action is done by the swimmer on the water by pushing the water in backward direction, and as a reaction the water pushes swimmer in forward direction. So there are many examples, walking, swimming, and there is a very important example that we will discuss later also, that is recoiling of gun. Now what is this recoiling of gun? See, when the bullet is fired from the gun, okay, you all have seen in movies that the bullet moves in forward direction with some speed. But the gun also moves in backward direction, giving jerk to the shoulder of shooter. Why? Because as the bullet is fired from the gun, okay, the bullet, it moves in forward direction, that is the action. Okay. But according to Newton's third law of motion, what will bullet do? Bullet also applies a reaction force on the gun. So the bullet moves in this direction, this is the action, and the bullet applies a reaction force in opposite direction on the gun. That's why when you shoot the bullet, the gun moves in backward direction, giving jerk to your shoulder. But the bullet does not move with same velocity as the bullet moves. The gun does not move. Why? Because of mass. Since F is equal to ma, so A is equal to F by m. Since the mass of the gun is very large, therefore the acceleration by the gun will be small. Okay, but it moves in backward direction. Now, with what velocity this gun will move in backward direction, or with what velocity the gun recoils, this we will study after we will discuss our next topic, that is law of conservation of momentum. So we will study the derivation. We will find the recoiling velocity of the gun with applying law of conservation of momentum. So moving on to the next topic, that is law of conservation of momentum.